So the warm-up is to get you thinking about what we're doing today. I know you talked about it in middle school. You read through the why, and then the target for today is that we really can work on drawing Lewis structures for any compound to work on 3D shape. Okay? So in the middle column here, or I should say the right on this paper, but we're going to be talking about what these actually look like in 3D space. So far we only talked about the molecules kind of existing in terms of writing out their formulas, but we need to talk about what shape they actually are and what they look like in 3D. Okay? So we do that with what we call Lewis structures. Now we're only focusing on covalently bound molecules because those are the ones that we know more about their structures and they're pretty fixed. Ionics do a weird thing where they just kind of line up in an organized pattern, okay? But the covalent structures, we can actually talk about them very strategically using Lewis dot structures. And then in the next part 17, we'll talk about what that looks like then in 3D space. This is kind of step one of two steps. So we're going to start by drawing Lewis structures, okay? Now these structures are going to use dots to represent the electrons. Now the outer shell electrons, because those valence electrons are what we care about from earlier in another part. So they're going to share their electrons to try to get full outer shells, okay? You can keep reading through this, but basically we talk about the octet rule like we've talked about before, okay? So they want a full octet of valence electrons, meaning they want 8. Here's the steps that we're going to take though, and we're going to practice this, but first we're going to talk about it. You calculate the total number of valence shell electrons, so taking into account any charges. Now it's kind of opposite. If you see a negative charge, you actually add them because we're counting electrons, so negative means it has more electrons. Subtract if it's positive. Then in step 2, you want to make sure you decide what atoms go in the middle. We call it the central atom. Okay, generally it's the one that there's only one of that particular element. We'll practice that in a minute. And then the third thing you want to do is you arrange the rest of them, whatever is involved in the compound, so different elements around the central atom. You want to use electrons, okay? We want to make sure we form bonds, so double or triple if we need to, okay? And then the bonding pair of electrons is used by a line to show that. So what that really means is that if we look at a line, think about connecting the dots, okay? So if we have a line, imagine like there's an electron here at the end of the line, an electron here, like you're doing a connected dot drawing, okay? So if you see a line, you're thinking that there's an electron on either side, and the line means it's shared between those two things, okay? Now, one of the most helpful things that students find when we talk about this kind of process in terms of valence shell electrons and drawing Lewis structures is to make a little what I call a cheat sheet table, which is what I have here in this table. So you want to write this somewhere in your notes just so you have it. Basically, this tells you based off of the column that the element's in, how many electrons it comes with. So in terms of valence electrons, so how many dots you count for it, and then how many bonds it wants to have. Hydrogen gets its own column here, okay, of this table, but it's just for hydrogen. Okay, it only has one valence electron, it only wants one more bond. But then boron, okay, 3 valence electrons wants 5 bonds. This is for carbon's entire column. Okay, so anything that is in the same column of the periodic table as carbon, 4 valence electrons wants 4 bonds. Nitrogen's column, anything there has 5, wants 3. And if you're thinking about it, 3 plus 5 is 8, 4 plus 4 is 8, 5 plus 3 is 8, 6 plus 2 is 8, 7 plus 1 is 8, and so forth, okay? So that's why those numbers exist there. Again, oxygen, anything its column has 6, wants 2 more. Fluorine has 7, wants 1, and anything in neon's column, you might see them in Lewis structures, but they already have that filled shell of 8. So they don't technically need any bonds, but if we're talking about there is a possibility, okay, so by the some atoms are exceptions down here, there is a possibility that they can take in more than 8 electrons, okay, and that's what they would do if they form a compound. So we're going to start actually practicing this. It's the only way it's going to make sense, okay? Now, when we start by practicing this, the first thing I want you to know is that you always start by counting the electrons, okay? Every time, that's where we're going to begin. After you count the electrons, then we start looking at, okay, what goes in the middle, putting the rest around it, and adding in those dots. So if we look at this first one here for F2, okay? With F2, that means there's 2 Fs. I hope that's pretty clear. I always write it like this, meaning E with a negative meaning electrons. So I'm adding up my electrons. You can write out the full word electrons however you want to, but I need to see some math, okay? Because that's showing me that you're counting the electrons, which you need to do because when we do Lewis dot structures, you have to have the right amount of electrons. So each F, if we come back to this cheat table here, okay, each F has 7 valence electrons. It wants 1 more. Okay, so we'll deal with that in a second. But right now we're counting up how many valence electrons it already has. So each F has 7, so 7. plus 7, because there's 2 of them. So that means we have 14 valence electrons at play. Okay? That means that you need to be showing 14 dots when we draw this whole structure. Remember, a line is 2 dots when we use a line. Okay? Now, do we have to worry about what's in the middle of our structure? That's the next thing we're going to go through. No, because there's only 2 things. Okay? So nothing's going to go in the middle. They're just going to kind of go next to each other. So you're going to write out the 2 symbols. So F, F, because there's literally 2 F's. We come back up to this table. Each F only wants 1 bond. Okay? So that means it's going to get 1 line. Okay? So I'm going to draw that here. 1 line. Now remember, you can draw the dots on either side if you want. Okay, I tend not to, but you can if you want to count. That's already 2 electrons. We need 14. That means we need to have 12 more drawn in here. Okay? But the idea is that every F, now that they have a bond between them, has 8 electrons around it. So this F has 2 electrons right now, 1, 2, okay, that it sees right around it. So that means it needs 6 more to get to 8. So we draw the dots in pairs around that particular atom, okay? So 3 pairs of 2, when we talk more about electrons later in the year, but they always exist in pairs, okay? So 2, 4, 6 electrons, 7, 8, okay? So we have to do the same thing over here. 3 pairs of 2 because it wants to have a total of 8, right? So those dots show you that it has 6 more electrons. When you think you're done, because I know that each F has 8 around it and it has the right number of bonds between it, I want to count them all. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And look, that number matches. That's why I needed that number. So that means I'm done. Okay? And that is the Lewis dot structure for F. Let's try O2. Start by counting up our electrons. Come back to my table. Okay? There are 6 valence electrons for each oxygen. There's 2 oxygens, so 6 plus 6, I get 12. I don't have to decide what goes in the middle because there's only 2 things. We'll practice that in a minute when you have to. The next thing I do is I think about, okay, how many bonds does each oxygen want? Well, each oxygen wants 2 from this table. That means we're going to have 2 lines between the oxygens because they're sharing a double bond, okay? Looks like an equal sign. If you want to put the dots again on either side, you can, but that's showing me that that's 4 electrons already. So 4 of the 8 are done. Now, each oxygen has to have 8 electrons near it. Right now, there's 4 next to each one. So that means I'm thinking, okay, so 8 minus 4 is already taken care of, so I need 4 more electrons. So I draw them in 2 pairs, because they always come in pairs. It doesn't matter if you put one on the top and one on the bottom, or one on the top, one on the side like I did. It does not matter, okay? They cannot go in the middle, though, because the bonds are already there. So I think I'm done because each oxygen has 8 near it, and I have the right number of bonds. So I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Matches, I'm done, okay? Try nitrogen. So my electron count starts there. Come up to this table if it helps. There's 5 valence electrons for each nitrogen. 5 plus 5. I get 10. Next thing I want to do is draw out my nitrogens. There's 2 of them, so just put them near each other. Okay? It doesn't really matter if you do top and bottom or left and right like I'm doing. Okay? But we just need them next to each other. Each nitrogen wants 3 bonds. So that means there's going to be a triple bond between them. Okay? Again, you can put the dots on either end if you want, but I know that these 3 bonds represent 6 electrons. So each nitrogen already has 6 near it, and we need to get to 8. So I'm just going to add 1 pair of dots for each nitrogen, because it only needed 2 more. They already had 6. I need to get to 8, so 2 more of them. I think I'm done because each nitrogen now has 8 near it, and there's the right number of bonds between it, so I count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Matches, we're done. Okay? Now, we're going to practice some more that don't have the exact same element each time, so we can kind of try that out. Here, start with our electron count as always. Okay, so I take electron. Hydrogen only has 1, so 1. Chlorine is in the same column as fluorine, so I'm using the same numbers, so 7. 1 plus 7 is 8. There's just an H and a Cl, okay, so I just put them near each other. But what's different for hydrogen that you're going to see is each hydrogen only ever wants 1 bond, okay, so I have to just put 1 line next to it. Hydrogen just gets 1 line next to it and no dots, because if you count 1 plus 1, it only wants 2 electrons near it, which it already has with the 1 bond. Chlorine, though, needs to have 8 near it. There's only 2, so I have to put 6 dots to get me to 8. I think I'm done because I have the right number of bonds between hydrogen and chlorine, so I go off of, by counting them, 1, 2, 3, 4, 5, 6, 7, 8, okay? So I have 2 at the bottom. Let me make them bigger here so you can see them. 2 on the side. and 2 on the top. Okay? So that's my final Lewis structure. Okay, looks like that. Try the next one. It has more than 2. Okay, so we've got P of 5. So my electron count, so I look at phosphorus. Okay, phosphorus is in the same column as nitrogen. So 5 plus 5 fluorines, each one has 7. So the phosphorus plus, in fact, there's 5, that number there, 5 fluorines, each one has 7. Okay, I add those all up, I get 40. Okay, so we got a lot more dots we're going to deal with here. So now I have to decide what goes in the middle because I have 1 P and 5 Fs. So hopefully you're thinking, okay, that seems common sense, okay, because there's only 1 P, and there's 5 of the Fs. The thing that there's only 1 of, the P, is going to be the thing that goes in the middle. So P, F, 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 F. I'm just literally drawing the Fs around the P, okay? I just tried to space them kind of evenly, but it doesn't matter otherwise. Now, whenever you have more than 2 things going on here, so more than 2 elements, we have 5 Fs and a P, you go off of the outside. So I'm looking at the fluorines. How many bonds does the fluorine want? Well, I come to this table, it only wants 1. So each fluorine just wants 1 line next to it. So I'm going to do that. Okay? Now I think to myself, each fluorine wants to have 8 electrons, so that line is 2. So I think, okay, they need 6 more to get the 8. So each fluorine is getting 6 dots because they need to have 8 electrons near them. They're drawn in pairs, kind of one on top, one on either side, okay, of the F. Now, notice that the P in the middle now has 5 bonds around it, okay? Technically, it's in the column with 3, but if they're in the middle, they can do some weird stuff and take in more electrons, so that's fine. So I'm going to go ahead and count, okay? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. That number matches, so it's done, okay? Let's try the next one. So PCl6 with a -1 charge. So I'm going to do my electron count. You always start there. P again is 5. There are 6 chlorines. Each one has 7 because it's in the same column as fluorine. So 6 for the fact that there's 6 there. Each one has 7. Now remember, if it's a negative charge, you actually add it, okay, because we're counting electrons. So 5 plus 35, I'm sorry, plus 42. 5 plus 42 plus 1, okay, we're looking at 48 here. Okay? So next thing I have to decide is which one's going to go in the middle. PCl6. There's 1 PL, 1 P, 6 CLs. You think to yourself, which one's by itself? Okay, so that's the P again. 6 CLs spread out throughout, okay, around the P. I go off the outside. So how many bonds does Cl want? Well, it's in the same as fluorine, so just 1. So I draw in 1 line. And then they also need to have 8 electrons near them, so there's 2 taken count of. So we need 6 more to get them to 8. So every single fluorine's getting 6 dots now in pairs of 2. Okay? Now, I'm going to add them up, make sure we're good. Okay? So we'll start down here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. Matches, I'm done. Okay? We're going to try 2 more here. Okay, we're going to skip the CBr4. You're going to get plenty of practice with this. So H2O, keep my electrons first. 2 H's, so 2 times 1, because each H only has 1 from up here, plus 6 for the oxygen, they have 8. Okay, I think to myself, what goes in the middle? Well, there's only 1 O and 2 H's, so O is going to go in the middle. This is water. I know you've seen this in bio. I go on the outside. Each H can only get 1 line. Okay, so that's all they get. And H's never get any dots. Okay, so I have right now 4 electrons being counted for. I need 8. So that means I need 4 more. They can only go on the middle because the H's can never get any dots. Okay, so I count 2, 4, 6, 8. Now I'm done. Okay, and the NH3 is very similar. We get 8 again. Okay, when we add them up because there's 5 plus 3 here from the hydrogens. What goes in the middle? So N and one of them. Everything on the outside, how many bonds does it want? Just 1 for hydrogen. 2, 4, 6, I need to get to 8.